we visualize and actually execute the merging of two sorted linked lists. So here are the two linked lists that we're given. Both are sorted. And so what we're going to do is, first of all, we're going to introduce a dummy node here at the beginning, which will keep track of the beginning of the merged list. Okay, and then we're going to go ahead and assign some pointers. So we'll use C for current. We'll set that to the dummy. Use F for first, as in first linked list, top linked list. S as in second, which are set to the heads of the two lists. All right, so here's an iteration of the algorithm. The iteration is the same for the first and the second and so on. So what we're going to do is we want to figure out which node to connect to C by setting C.next equal to either F or S. And so we're going to compare the two values of F and S to see if F is less than or equal to S. In this case it is, so we're going to connect to F. So we're going to set C.next equal to F. Okay. And now we're going to shift the pointers. So we're going to move C to be equal to F to keep track of kind of the current node of our merged list. And then because we consumed F, we're going to slide F over to F.next to keep track of the unmerged portion of F. And again, important to keep in mind here that we're doing this all in place, and things are a little bit wonky right now because C has all of F downstream. Of course, that's not sorted. That's not the final result, but it is fine in the context of the algorithm, which you'll see, because we're just going to effectively just kind of manipulate these pointers like in this 2D space, connecting things across lists and within lists and things like that. And actually, I think I'm going to make this a little bit more interesting. So 2, 3, 4. Gotta make this 3, 2, 2, 3. Make this 3. Make this 4. Yeah, okay, let's try this. Okay, so now we're at C, and we've completed our first iteration. Second iteration, same algorithm. Compare F and S, current pointers. In this case, S is less than, so we're going to set C.next to S. Okay, we're going to move C over to this new node we just consumed, and then move S over to S.next to keep track of the remainder of this list. Okay, then again, same deal. We're looking at F and S. In this case, F is less than S, 2 less than 4. So C.next will be set to F. We'll move C to F. We'll slide F over. Okay, in this case, we're comparing F and S again. 3 is less than 4. So we're going to keep this connection, although in the code you'll see that we actually just go ahead and set it explicitly. We don't really account for the fact that it was already set. We just kind of naively or simply set C.next equal to F, even though it's already set. It's just simpler that way. So C.next equal to F. We slide C over, and we slide F over. Okay, so now we're at 3 here, and notice at this point now we have all the way up to C we have a sorted list here. So anyways, so now we compare f and s in this case. S is less than, so we're gonna set c.next equal to s. We're gonna slide c over to the node we just consumed, then slide s over here. Then again, I'm going to compare f and s. In this case, s is less than, so we're going to set c equals c.next, slide c over, slide s over. Okay, so in this case, or in this situation, s is set to none, which indicates the end of our while loop. So we're going to kick out of the while loop, and then we have to account for the fact that it's possible that there's like either f or s, never both, but maybe one are still have elements not merged in, and so we want to check for that and go ahead and if there is a non-null f or s, we're just going to connect it to our list here like this. All right, so that's how we think about it, visualize it, and how we execute the algorithm.